Okay, so in this video, we're going to take a look at the equation of the line and how to use it. So this is the 2013 question 3 on paper 2, and it is a good example of manipulating equations to extract information. So one very important thing that you need to remember about the line and the equation of the line is that if you can write any linear equation in the format of y equals mx plus c, you can tell everything that you need to know about that line by looking at the equation. You can tell what the slope is by looking at the number in front of the x, and you can tell what the intercept is by looking at the constant. So in this question, in 2013, you're asked to look at some equations and then answer some questions. So which has a slope of 2, which is an intersect with the y-axis of 0 minus 2.5, a line which makes equal intercepts with the axes, a line which makes an angle of 150 with the positive sense of the x-axis, and two lines which are perpendicular to each other. So we're asked to organise these lines. Now, what you will have to do for yourself is learn how to manipulate the equation of the line and read the equation, which is y equals mx plus c. So what we have here are the equations. And what we'll need to do is rearrange each of these so that we get y equals something x plus something. So this is what I have here, is I'm going to rearrange this. So I'm going to, if I rearrange that, I could bring the y over, so plus y to both sides and minus x from both sides. That becomes y equals 3 minus x in this case. Or if I want to structure it a bit better, I could say y equals minus x plus 3. Because then it is in the format for us, y equals some number by x plus a constant. So that's what we have there. If I look at the next one is 2x minus 4y is equal to 3. So what I'm going to need to do there is I can say take 2x from both sides, and what I get is minus 4y is equal to minus 2x plus 3. And I can divide everything by minus 4, and I'm going to get y equals 1/2 x, because minus 2 divided by minus 4 will give us 1/2. And then we're going to have plus 3 divided by minus 4, so I get minus 3/4. So that's what we have there. So y equals mx plus constant. The next one. In this scenario, they've done a lot of the work for us. They've actually just factorised that minus 1/4 out. But if I do that, I'm going to have y equals minus 1/2 x plus 7/4. And I'll just move that over if I can, just to move him over so that we can see him a bit better there. The next one we're going to do is we're going to have, right, so I could just bring the 2y over, or say plus 2y to both sides. So I could really rearrange that and get 2y is equal to 4x minus 5. And that then could become y equals 2x minus 5/2. Then I could have here, this one, I could rearrange this to be, let's see, so I could bring the x and the 10 over, or I could say minus x from both sides and plus 10 on both sides. So what I'm going to get is root 3y is equal to minus x plus 10, which will result in us getting y equals minus 1/root 3x. That's a minus there. Minus 1/root 3x plus 10/root 3. So there we have that one. And then the last one that we have here, if we write that one out, what we will get here is we will get y equals, take away root 3x from both sides, take away that, and then we're going to have plus 10 when I add 10 to both sides, like that. So there I have each of them in the format y equals mx plus c, and we said we can tell everything that we need to know from that. So I'm going to put them all up here so that we can see them. So I'm going to copy that as well and bring them all over here so that we can see them just that little bit more clearly. So in each case, we've rearranged them, and if I have it rearranged in the formula y equals mx plus c, I can tell by looking at that equation what the slope is, what the intercept is, and you can actually plot that graph very, very quickly as a result. So they are going in alphabetical order, so that's what we need to remember as well when we go to match them. Okay, so there is our equations for each line, and then we're asked to find a line that has a slope of 2. Now remember, we told ourselves that if we write any equation in the line y equals mx plus c, then straight away m is going to be the slope and c is going to be the intercept. So if I'm looking for a slope of 2, I'm looking for a value of m, the number in front of the x, to be 2. And if we look at all of the options that we have there, it's going to be the purple one here, which was L. So line L is what we get for the first one, because it has the number in front of our 2, or in front of our x is 2. So that line L is what we're going to have there. The next one, a line which intersects the y-axis at 0, minus 2.5. Now, what we know about the y-intercept, or the point where it intersects the y-axis, is that's always going to be the plus c in this formula. That's what the plus c gives us. So we're looking for a graph that gives us minus 2.5 as the constant. So if we scroll down and we have a look at all the ones that we have, that's a positive 3, so it's not what we're looking for. Minus 3/4, not what we're looking for. 7/4, and it's a positive, not what we're looking for. But then we have minus 5/2, and minus 5/2, if we were to divide that out, would give us minus 2.5. So there we have, once again, line L for us. Now, the next one, a line which makes equal intercepts on the axis. Now, what that means is that if we have a line and it cuts the y-axis at 2, it's also going to cut the x-axis at 2. So we'd have a line like this that would go through both like that. So it cuts it at equal intercepts. So we're looking for that sort of scenario. So we're looking to see where we would have a value of x or y where they're both going to be equal to the same thing. And if we're looking at that, then let's go down and have a look at our equations here. So what we have is, if I'm intersecting the x-axis, what we know is that we are neither up or down on the axis. So I know that the value of the intercept at the x-axis of y is equal to 0, and I know at that stage here that x is equal to 0. So what you're going to do is sub in 0 for y here and see what you get. So if I subbed in 0 for y here, what I would get if I did that out. So if I do y is equal to 0, what I get is 0 is equal to minus x plus 3, which I could do x is equal to 3. If I go for x is equal to 0, let's check that out. What do I get? I get x is equal to 0, so I've got y is equal to 0 plus 3. So I get y is equal to 3. And in that scenario, straight away, nice and easy, we've actually found it. So the very first one worked out to have equal intercepts on each of the axes. So h is what we can write in here for ourselves. Now, the next thing that we're being asked to do is we're being asked to find a line which makes an angle of 150 on the positive sense of the x-axis. Now this is something that perhaps we haven't talked about too much. So I'm going to just clear this for us so we can take a look at that. So we're being asked to find where it makes an angle of 150. Now, what is the connection between angles and linear graphs? The slope is given by the change in y over the change in x, all right? Another way that you can get the change in y over the change in x would be if we had, for example, the change in y would be the up and down, and the change in x would be the left to right. And if we were looking for the angle that that line makes, that angle there, we'd be looking for the opposite over the adjacent. So what we're really looking for is we're looking for tan of the angle. So tan of the angle is equal to the slope. So if we can get each of these, if we can analyze each of these for tan of the angle is equal to the slope and figure out which one will give us 150, that's what we need to figure out. So remember that tan of the angle is linked to the slope. So let's take a look. So if I do this one, my slope is equal to -1. So if I do that, I'm going to have tan of the angle is equal to -1. So my angle is equal to tan inverse of -1. So if we put that into our calculator, tan inverse of -1, we get 45 degrees. So not quite what we're looking for there. If we do the next one, if I do tan alpha is equal to 1/2, what we're looking for there is we're going to do tan of the angle is equal to 1/2, so we have 0.5, so tan inverse of that, which gives us 26.56. Still not quite what we're looking for. And 26.5, so degrees, not what we're looking for. What about if we did tan inverse of -1/2? Well, then we would have just that but negative, and it would be the same here as well. Now the negative doesn't necessarily mean it's negative angle, it just means it's in the negative quadrant, which you'll need to go back and think about your trigonometry and your cast circle when you're thinking about that. So we just get a negative here when we're thinking of that. So theta is equal to that. Not quite what we're looking for yet. So tan alpha, what about tan alpha, or sorry, tan theta? It's not an alpha, tan theta is equal to 2. So if we get tan inverse of that, so tan inverse of 2 works out to be 63.434. So still not what we're looking for. Tan inverse then of the next guy. So if tan of the angle is equal to the slope in this case is going to be -1 over √3. So the angle is going to be equal to tan inverse of -1 all over √3. And we get a -30. And what we will get here in the last instance is we will get tan alpha is equal to -√3. So -√3. So what we will get is theta is equal to tan inverse of -√3, which gives us -60. So what we have here is none of them so far have worked out to be 150 for us. So what we need to do is connect our ideas of trigonometry to the line and what that might look like. So the ones that we know straight away that are not going to result in any changes are the positive sense. These ones are coming from this quadrant up here, right? So you've got your angle, or the other place that it could occur is in the tan. So what you have here is you have that all angles are positive here, sine, cos and tan. In this direction, your cos is negative and your sine is positive. So its sine is going to be positive there. In this scenario, your cos is negative, your sine is negative. So those are both negative, but your tan is positive. And in this area here, your cos, your x direction is positive and your sine is negative. So you've got a C there. So what we actually have in the negative sense, we could have it down here or down here, up here. But we know that the 150 would be somewhere here. If I was to have a line going this way, my angle of 150 with the x-axis would be starting at 0 here and spinning around this way. So what I'm looking for is an angle that allows that to result in 150. So the angle in here is what we're focusing on. Now, what I know is that that's 90, that's 180, this here is 270, and this goes back to 360, and it's also 0. So what I know is that whatever this angle is here, it has to be enough to have 180 take away that angle, and I'm going to have 150, because that's what we're aiming at here, is that it makes an angle of 150 degrees, that angle there. And if you look at what we have, the one that will give us 180 and that angle, which is minus 30, will give us 150. So it's this answer here. So the line that gives us that is going to be the second last line, so our yellow line, which was line M. So a bit of trigonometry coming into our coordinate geometry there. So just using the cast circle and the fact that tan is linked to the slope. The tan of the angle will also give you the slope of that line. Very, very important. And now the last thing, I'm going to clear all of this now to give us the last thing, which is slopes that are perpendicular to each other. So lines that are perpendicular, they do intersect and they meet at a 90-degree angle. So perpendicular lines do meet, and they meet at 90-degree angles. So our axes on the coordinate plane, those are perpendicular lines. Now the other thing we know is that if you have two slopes, slope number 1, and you multiply it by slope number 2, if those two multiplied together give us minus 1, then they are perpendicular. And the way I've always remembered it is, if I have perpendicular lines, I can flip the slope and change the sign. So I'm looking for slopes that are inverse fractions. So they're the reciprocal of the other, and then we change the signs. I'm looking for example, if I was looking for a half, I'd be looking for 2 over 1, and it would be a minus 2 over 1. I don't have that. If I was looking for minus 1x, so the slope there is minus 1, I'd be looking for a positive 1, which I don't see there either. So do I have minus 2? I don't. Do I have, now what would I expect here? I'd expect to have, flip that, so 2 over 1, change the sign, and I'd go to 2. There we have them. Okay, so just to make sure that I don't have any other ones, so I'm saying that these two actually did, because perpendicular lines, flip the slope, change the sign. I can confirm that by multiplying them. And if it equals minus 1, which minus 2 over 2 is what we will get here, that will equal to minus 1. Checking out the other ones then, so if I was to get the perpendicular slope to this, flip the slope, becomes root 3 over 1, and it becomes a positive. So while these are very close, the sign is wrong for them to be perpendicular. So we know that the two that we have is the green line and the dark purple, so that's going to be line K and line L. And there we have it.